Hey y'all, Data Guy here. And today I have an Apache Spark script for you that I've come up with that is basically just kind of proof of concept for showing how you can use Apache Spark to detect and then respond to cybersecurity threats by analyzing large volumes of network traffic, logs, and security events in real time. So the script is going to include data ingestion of those different network traffic, logs, and security events, processing that, normalizing it, making it easy to consume, then actually parsing it for threat detection. So looking for any anomalous interactions, anything out of the norm, ordinary, showing you how to build that logic, and then also showing you then how to take the responses for understanding what actually has gone wrong, what was the issue there, and turning that into a response that can then be propagated to some kind of alerting system and put in a human readable report. So that's what we're going to enter today, and we're going to start just by creating a new PySpark file. So just going to create new Python file, just save this as fraud detection, Spark, and save as fraud detection. Save it in my data guy repo, and boom. Cool. So now we can start building our script. And also, if you're looking at how to run Spark locally or test this locally, check out my previous video on actually how to do that. It'll just show you how to set up a really simple, easy to use local Spark testing environment. So the first thing we're going to now do with the script, as we do with all of our scripts, is import a series of different packages and requirements. So here, nothing really too crazy, just a Spark session to actually initialize a Spark environment and session for us to use, column for interacting with columns, from JSON for pulling data from JSON files, window for allowing us to kind of take a snapshot of a data set, count for counting, average for taking an average, and then struct type, struct field to allow us to create our own custom types and objects within Spark, and then we have string type, timestamp type, and integer type for just some standard data types. And then here we have data stream writer, which will allow us to write to a data stream as well as read from it. So now that we have our relatively short list of packages and requirements in, we'll just initialize a Spark session at the start of this script and not actually try and run it here. So here we're just going to create an app name, Spark session builder, real-time cybersecurity threat detection, getter create. And then what we'll do next is define a schema for ingesting our network traffic data. So here we're going to have network traffic schema defined as timestamp, source IP, destination IP, protocol, and the amount of bytes that's actually transferred. So that'll allow us just to have a common format for all of our different network traffic data that we can then process. And then we'll also create a separate schema for log data. So here we'll just have the timestamp, the log level, which is like severe, critical, error, warning, etc. And then the actual message contained within that log entry. And then finally, we'll have another schema for security events. So here we have our struct type. We're just having timestamp, event type, and the description of these security events. So we again have a common format for the security events. Then what we'll do now is I'm going to mimic as if we were pulling from Kafka as a data source here. So what we're going to do is use the Spark read stream function to pull data from a Kafka topic. So subscribing to the Kafka topic of network traffic. And what this will have the effect of doing is loading data from the stream that's been populated and then reading it from that JSON. So casting the string, getting the value from there, and then using this network schema as the format for storing our data. And then what we're doing is once we select the data from that format, pulling all the relevant data from that topic, and then storing it within our network traffic data frame so we have it in that more structured format. So now that we have our network traffic collected from our stream, we're then also going to collect our logs. And again, sorry, I keep forgetting Shift Enter. I don't need to do that here. So here we're going to collect logs from, again, another Spark topic. So here we're subscribing to a log stream. And again, selecting from that JSON the different values for each column, casting them as strings, putting them into our log schema, and then selecting data all now that's in the schema and saving it again into our logs data frame. And then finally, we will just do that a third time, similarly for the security events data frame we created. So I won't spend too much time here again, but all we're doing is just, again, reading the stream from a different topic, subscribing to security events, casting the values as strings, and then just saving them into that security events data frame. So now that we have the data, now I want to show you the fun part, which is actually, hey, let's try and analyze this data for anomalies. And so the first thing we'll do is, let's see if there's a really high volume of traffic from a single source IP. And so to do that, what we can do is take our network traffic data frame, group it by timestamp on the minute by minute basis, and then sort for the source IP column. And then we're going to count the total of bytes used by each source IP, so aggregate every entry for each source IP. So even if a source IP makes tons of different small entries, we'll still correlate those to understand that they're using a lot of data overall. And then filter for people that are using more than 1 million bytes, because that is what we deem as anomalous on our environment. That's like a gigabyte of data, or not a gigabyte, it's actually a really small amount of data, but still, good checker. So now, any source IP that we detect as having excess traffic, will then flag and add to this traffic volume data frame. So you want to immediately alert on it, but instead, in case there's multiple source IPs that are potentially making bad login attempts, we can just collect those here. And then what we'll also do is detect for any failed login attempts. Lots of failed login. I mean, everyone forgets their password, but lots of failed login attempts is typically a sign that someone is trying to brute force log into someone's account. And so great way to check that is, hey, let's look for any errors that have the message like failed login, group them by timestamp on the 1 minute mark, so every 1 minute, collecting data about failed logs, and then detecting, hey, if you have more than 5 failed logins, let's add that to a failed login data frame. That's likely a source of someone trying to gain access to an account they're not supposed to have access to. So great way of just collecting those users so that you have them in an easy to notify on data frame. And then finally, just a really basic specific security event. So here we can just filter for any event type where there's malware detected or unauthorized access. And this is just more for those base initial level security events, just saying, hey, was there an issue here? Even if your first line security defense is capturing it, make sure that you're saving all that information in a database. It's then easily servable to the response team. And you also have that historical information of, hey, the malware was detected on this entry from this source IP, and you can go back and collate it and look at that later. So now that we have all of our different log and learning data and some easy to use data frames, let's then add them all into one single potential threat data frame. So here, just adding union on failed login, specific events data frame, and then now we have all these collated into just one easy to use data frame. Let's show you how you can alert on it. So now for the alerting logic, I'm going to bring in a few different additional packages that we're then going to use for showing you how you can log these alerts either to a database, to email, or to SMS, or also if you want to take automated actions based on the alerts. So first, we're going to go back up to the import section, and we're going to import a few different libraries. So here, we're going to bring in here smtlib. And let me just import these here. So importing a couple different tools that will basically just allow us to structure, send emails, Twilio, and then also just connection libraries. So we'll import here, we'll have, Cycog PG2 and subprocess. These are just for interacting with external services from Spark. And then emails for sending email, SMTP is for sending messages over SMTP. So here what we'll do now is define how we're going to handle our threats. So first one we're going to have is log to database. So in this case, we're just going to take whatever the threat was and then log it to our database. So here what we'll do is use psycho-pg to connect to your database. In this case, probably just like something Postgres, so your database, username, password, host, and port. And then insert query, we can insert our threats into our timestamp, source IP, and the description of the threat. Execute that query. So basically just bulk loading all the different threats with their timestamp, source IP, and the description of the threat into our backend log database. And then just committing that and closing that out. So that's one way if you just want to store them in a backend database. Then if you want to send email alerts based on whatever went wrong with your with your system, whatever you detected in terms of your monitoring system, you can send an email alert here. So here you'll have your sender email, which is whatever email you actually own the rights to, your receiver email, and your password for your email, because we're going to need to use that to log into it. And then this is where that my multi-part email creator comes into play. So creating an alternative email type, and so here we're having the message building the subject header, the from email, the to email, and then using Jinja templating to effectively just build a text message that incorporates the different pieces of information, so the threat, timestamp, source IP, and description, attaching that to our email, and then sending that over SMTP. So here, using that SMTP example, so whatever SMTP server you actually control, logging into that, and then sending that email that we've built using MIME as a message here. So my message as string. So just a really quick and easy way of getting automated emailing alerts there. And then finally, we'll use Twilio for SMS alerts. So here, and this is, you would need to actually have a Twilio account here, but you could send an SMS alert by logging into Twilio via their auth token and your account ID, log into their client, and then create a message from your Twilio number to whatever number you want to receive, or you could feed this an array of all of your on-call engineers if you really want to piss them off. And have this essentially send the same information. So threat was detected from an IP source at timestamp. So here, since it's an SMS, kind of cutting down on the amount of text actually included. So then someone can go in, and you probably want to pair this with a backend database logging functionality, because then they can go in and say, hey, look up this source IP to actually figure out what the description was. Now, also, if you want to have kind of automated functions that do things like block the IP of any address that receives or causes errors, you can have the subprocess that runs that'll take their IP address and say, hey, isolate the system. If you detect network traffic coming from this, just say, hey, isolate that system and block that IP. And then to incorporate this all into our streaming logic, so what we'll do here is now bring it all together. And so here we have handle threats. So here our function handle threats is essentially what's going to take our threats data frame, so the threats that we detected and collated from all these different so potential threats data frames. Let me actually change that. Oh yeah, no, we have it. Okay, cool. So showing our detected threats, then for each row in detected threats, logging that to each database, setting an email alert based on the context of that threat, also setting an SMS alert, obviously you probably choose one or the other, and then conducting automated actions too, like blocking IP from any threat. So if you wanted to say, hey, block that IP of the source IP that for this row, if there's a threat, this would this is how you would implement that action for those kind of more automated response. And then here, the write stream is just writing all your threats to a sink. So also you can have this feed into a backend console, and then also applying the response logic and making sure everything is processed. And that's really all I have for you today. So just wanted to make a video for you showing you how to do fraud detection with Spark, since it's a really common use case and a really helpful one. So I hope you enjoyed this video. Have a good rest of your day. Data Guy out.